Hey guys, today we're going to be focusing on writing and graphing systems. This is going to be a two-part lesson. Our primary focus for today is going to be on the writing portion of systems, and the focus for our next lesson will be on graphing them. Now systems, when we talk about systems, we're talking about two linear equations that share either a similar solution, no solution, or infinitely many solutions. So that's what we're going to be discussing right now, is those three types. So the three types of systems. Our first one is what I just titled the one solution. So a one solution system means that when you are graphing them, so if you have your coordinate grid and you graph the two linear equations, at some point they intersect each other. So that would be considered to be a solution. It's the point that they overlap. Okay? Then you've got what we would title a no solution. So no solution is very, very unique. When you graph it, and you graph your lines, they will never touch. They will never intersect. So they are a set of parallel linear functions or linear systems. That means that when you're looking at them as an equation, both lines are going to share the exact same slope. They're going to have the same rise over run, but they're going to start at different y-intercepts. So if you're looking at it, my first line that I drew has a y-intercept that's in the negative zone. My second line has a y-intercept in the positive zone, but they both are increasing. They're both rising and running the exact same amount. So that way they will never touch. Okay, then you've got the third system that we talk about, which is infinitely many solutions, or similar to what we were talking about before when we were solving just a single equation. So with infinitely many solutions for a system, it basically looks like it's one line. If you graph it, okay, I'm going to graph my system. Oh, and then I need to graph my next line, and they happen to be the exact same line. So they overlap, okay? And they overlap everywhere. So that means not only do they have the same slope, but now they also have the same y-intercept. Okay, so that information is very, very important. And then once again, because some of you are still struggling with that graphing component, I want to talk to you guys about how you're going to graph. So how to graph. The first thing that you need to make sure you're doing is that you graph the y-intercept first. You have to graph your y-intercept. Your second ruling is that you're going to use the slope as directions. We're going to use the slope as a directional piece. Okay, so remember, if it's a positive slope, if your slope happens to be a positive slope, you have two ways that you can move. You can go up and to the right, a positive over a positive, okay? Or you can go down and then go to the left, because that's a negative over a negative, and remember, a negative over a negative is still a positive. If we need to go for a negative slope, for a negative slope, that means you're going to go up, which is a positive, but then you're going to go to the left, which is a negative. Positive over a negative gives you a negative. Or the direct opposite. You can go down, which is a negative, and then go to the right, which is a positive. So a negative over a positive would give you a negative slope. So this is how you would focus on graphing when it's in y-intercept, or I'm sorry, slope-intercept form. If it's in a standard form, you can solve for your x and y intercepts and plot those 2 points and then connect them. That's a perfectly legit system as well. All right, so let's go ahead and focus on just writing our systems. So given word problems, how to translate that into a system. So we have Miss Baker, and she bought 14 packs of red and green paper. We don't know how much red, we don't know how much green, we just know that together there are 14 packs of them. And there are a total of 72 reams of paper. Okay, so a pack of paper is like a box. The box might have 5 reams or 10 reams or however many reams of paper. A ream of paper is literally, when you see me opening up a ream of paper to put into the printer, it's all wrapped up, that's called a ream of paper. A pack is, another way, I should just say box, 14 boxes, we'll say that, so that way you guys don't get confused. 14 boxes of red and green paper, and then we've got 72 reams of paper within those boxes. Okay? Now, the red packs, or red boxes, we'll say. The red boxes come with 6 reams each. And the green boxes come with 4 reams each. Okay, so this is our format. Now we want to go ahead and write our system. So the first thing that you need to do is you need to label what your variables are going to represent. So identifying your variables. It's very important that you identify what the variables are, because if you don't identify them or label what your variables are going to represent, it could change your system around. So in this instance, I'm going to go ahead and say that my X is going to represent my red, and that my Y is going to represent my green. So X is going to be for red, Y is going to be for green. So within the problem, the first thing that I notice is it says that I have 14 boxes, right? 14 boxes of red and green paper. Okay, so I'm going to go ahead and write that down. 14 boxes of red and green. So I don't know how much red, how much green, but I do know that together it's going to create 14. So that would give me the equation x plus y is equal to 14. If I add my red and I add my green, it's going to give me 14 boxes. Okay? Now the next thing that I notice is I have a total of 72 reams. And in each of the boxes, my red has 6 reams each, and my green has 4 reams each. Okay, so let's write that information. We have 6 red each and 4 green each for a total of 72. 6 red each, 4 green each. It's a total of 72. Okay, so the keyword each means that this is a coefficient. So 6 red each means that I have 6x. 4 green each means I have 4y. And when I combine those together, it gives me a total of 72. So then here are my two equations for my system. I have x plus y is equal to 14, and 6x plus 4y is equal to 72. Okay, now tomorrow we'll focus on the graphing component for those, or Monday. All right, let's go ahead. We're going to do 2 more practice word problems, and then you're going to have your assignment. Okay, so we have Greg's Motors has motorcycles. Okay, that means that they have 2 wheels, right? Motorcycles are 2 wheels. And he's got ATVs. And your ATVs are 4 wheels. And the store has 45 vehicles. Okay, in case you don't know, vehicle is just another term for, a car, a motorcycle, an ATV, that kind of thing. So he only sells motorcycles and ATVs, so he's got 45 motorcycles and ATVs combined. That together have 130 wheels. Okay, so if he takes all the motorcycles, 2 wheels, and all the ATVs, 4 wheels, and combines all those wheels together, it's 130 wheels for the amount of vehicles he has in store. All right, so again, first thing that you want to do, and if you want to pause and try this on your own, that's perfectly fine. But the first thing that you're going to want to do is identify your variables. Okay, which thing is going to be labeled X, what's going to be labeled our Y. So for me, I'm going to go ahead and say X is motorcycles. And that Y is going to be my ATVs. So X is motorcycles, Y is ATVs. All right. So the first thing I know is, hey, if I take the store has 45 vehicles. They have motorcycles and ATVs combined, it's going to be equal to 45. So if I take all my motorcycles and combine it with all my ATVs, I've got 45 vehicles. Take all my motorcycles, all my ATVs, gives me 45 vehicles. So X plus Y is equal to 45. Okay, then I need to take note that, hey, all my motorcycles, they have 2 wheels. All my ATVs have 4 wheels, and now I've got a total of 130 wheels. So if my motorcycles have 2 wheels each, that would give me 2x, 2 wheels per motorcycle. Plus, my ATVs have 4 wheels each. That means I have 4y. 4 wheels per ATV. So if I take the number of motorcycles and multiply it by 2, and then take the number of ATVs and multiply it by 4, and combine that together, it gives me 130 wheels. Okay, and there's your system. Let's do one more. All right, Creative Crafts is going to give scrapbooking lessons. For $15 per hour. Plus a $10 supply charge. Okay, then you've got Scrapbooks Incorporated is also going to be giving lessons. So they give lessons for $20 per hour. And no additional charges. So they're not going to charge anything. All right, let's go ahead and get writing. The first thing that we want to identify are variables. So here, the things that I need to be focusing on, how many hours? How many hours of lessons am I going to be taking? So X can be representing the hours. And then what's my total cost? What's the total cost going to come out to be? So Y would represent my total cost. And I have two different stores that I'm going to be using. Two different stores that are providing me lessons and a charge. Okay, so let's focus on the first store. The first store is that Creative Crafts that's going to give scrapbooking lessons for $15 per hour. $15 per hour. That means every hour I'm paying $15. So that would be written as 15x. Plus they're going to charge me $10 for supplies. So right there, plus $10 for my supplies, and that's going to be equal to Y. So Y equals 15x plus 10, right? My total cost is $15 per hour plus a $10 supply charge. Okay, my second store, Scrapbooks Incorporated, they're going to give me lessons for $20 per hour. So that's every hour I'm paying $20 and no additional charges. No additional charges. So $20 for every hour and no additional charges means I don't have anything that I'm adding to this. That means my y-intercept is going to be 0, right? I could put plus 0 if I wanted to, but there's no reason to. And that would give me my total charge, my total cost. So my total cost for Scrapbooks Incorporated is going to be $20 per hour, no other additional fees. Okay, and then there's my system. All right, in our next lesson, we'll focus on actually graphing these three systems that we created, and then we're also going to do some additional systems for graphing practice. Go ahead and get started on your assignment.